two zeros on the output, but these values, this combination are not permitted because Q bar, the value must outside.
Yes, sir.
So
This is forbidden, sir.
this condition is not permitted.
Delay.
The active load is electric latch is in a stable condition when both inputs are high. So S bar R bar latch. So S bar R bar H, we must change the truth table to when S R when SR, then the output will Q bar and S bar equals 1, R equals 1, so then the output will be 0, 1, and there will be 1, 0, and it will be S bar 0, S bar 0, 0, 1, 1. The output will be 1, 1. Right? Right? Please see the PPT. Zero in what? So 0 in what the output will be 1. 1 plus any value equals to 1. Right? Right? This means on inverter. This symbol means represent all gate. On all gate. So S bar equal inverse to S. So S bar equals 0, then the output will be 1. 1 plus any value equals 1. Also, this input 0, so the output is 1. 1 plus any value equals to 1.
Yes. We just change this inverter and font size. Inverter.
Yes. Let S bar S. Invert. If we change the inverter to this position, right? The two inverters are moved to this position. Then S bar or S bar, Q bar plus maybe it is right. S bar, Q bar. S bar, Q bar, S R bar, plus bar. Right? It is equal to S and R, right? So when S bar equals 0, R bar equals 0, S bar equals 0, R bar equals 0, then the output will be 1, right? Q equals, and Q bar, S bar,
That 0 is 1.
not R bar, Q bar, right?
Yes, sir.
Q bar. So Q equals S and Q. The input is Q bar, right? Q bar, the signal to this. So Q bar, the input is Q bar. So if we move the two inward to this position.
0, 0. Because your input is 1, 1, 1 is okay.
I think if we move the two inward to this position, then the function will be the same.
Yes.
Will be the same.
Because this is not gate.
Yeah.
Or gate.
Yes.
So if our inverter is changed, this is no problem.
Yes. Yes. Because S bar plus Q bar equals S and Q. And for the original symbol, for the original diagram, we know that Q equals to the output of the inverter is S. The output of this inverter is Q, right? Because this is Q bar, right? Q bar, right? If the inverters are the original position, then S bar, so the output is S. Q bar, right? Q bar. So the output of this inverter is Q. So then the output will be S plus Q. S plus Q.
Yes, this 2 bar is cancelled.
And S plus Q. Translated S
Dot Q.
and Q. S and Q. Oh, so the OR gate must be changed to AND gate. AND gate. So
2 double.
so the
2 bar.
we will know the so we will represent the gate to NAND gate. And the last is NAND. Right? If we want to move the two inverters to the output we must change the OR gate to AND gate. AND gate. So this gate will be NAND gate. NAND gate. NAND gate. AND gate. AND gate. Q equal to S and Q, right?
Q
And Q bar equal to Q bar R plus Q bar, right? R plus Q bar. So S bar, when S bar equals 0, R bar equals 0. Then Q equals 1, Q bar equals 1. When S bar equals 1, R bar equals 0, then SI equals 1. S bar equals 1, so S equals 0. 0 plus Q equals Q. Q equals Q. And Q bar equals 0, so or R bar equals 0, so R equals 1. So Q bar equals 1. Q bar equals 1. Then because Q bar equals 1, because Q bar equals 1, then will be 0. S bar equals 1, 0. So then Q will be 0. Q will be 0. Q will be 0. Q will be 0. Right? Right?
I'm going to make that this is equal 1.
First time Q equals to Q, right? Because S bar equals 1, so S equals to 0. 0 plus Q equals to Q. So Q equals to Q. But Q bar, because Q bar equals to 1.
So Q equals 0.
Yes, so because Q bar equals to 1, 0. 0 plus 0 equals to 0. So Q equals to 0. And remain this value. So it equals to 0.
R equals 0.
And S bar equals 0. R bar equals to 1. Then Q equals 1. Q bar equals to 0. Because S bar equals 0. So S equals to 1. Right? S equals to 1. Then Q equals to Q. Q equals to Q. Q equals to 1. Q equals to 1. Because R bar equals to 1. So the output will be 0. Will be 0. And Q equals to 1. 1 will be 0. The output will be 0. So 0 plus 0. So the output Q bar will be 0. Right.
One minute, sir.
because Q equals to 1, right?
Q equal 1.
Q equals to 1. Because according to this,
0. So A Q.
S equals to 1. 1 plus any value equals to 1.
Yes.
So Q equals to 1.
Yes.
So Q equals to 1. So equals to 1 and R bar equals to 1, right?
Yes.
So the output is 0.
0. Yes.
And the output is 0.
So
Then
0.
0 plus 0 is equal to 0. So Q bar equal to 0. Right? So Q bar equals to 0. So R bar is a reset input. Is a reset input because this combination will make the output Q equals to 0. And S bar is the set input. Is the set input. Because if S bar equals to 0, then this combination will make the output Q equals to 1. Make Q equals to 1. So if the output is high active, is high value, the output is high value. We mean set. We mean set. The input set. And if the output Q equals to 0, Q bar equals to 1, then we mean reset. Reset. You must know the definition of reset and set.
Yes.
If we want to set a value, then we mean the output Q equals 1 to 1 and Q bar equals to 0. And if we say we want to reset the latch, then the output Q equals to 0. And yeah. And the last combination, S bar equals to 1, R bar equals to 1. Then R bar equals to 1, so R equals to 0. S bar equals to 1, so S equals to 0. So Q equals to Q. Q bar equals to Q bar. So the value will remain. The value will remain. The three modes of basic effort are operation. The first memory load. Two possibilities for the stack operation. Outputs make transmission when S bar goes low. When S bar goes from 1 to 0 and remain in same state after S bar goes back high. When S bar equals to 1, R bar equals to 1, S bar, R bar equals to 1, then Q equals Q. So the value will remain. And when S bar equals to 0, then the output Q will remain to go to high value, high level, and Q bar will go to low level. Right? That's how to reset. The start value is supposed to 0. So the start value is 0. We suppose that the initial value of Q is 0. Also, we can we can suppose that the initial value is pi is 1. Then no transitions occur. No transitions occur because the latch is already set. Q is already equals to 1.
So Q will be
So this is two possibilities for the set operation. And two possibilities for the reset operation. Then S bar always equals to 1. S bar always equals to 1. And R bar is from 1 to 0 and then from 0 to 1. 1 to 0 and then 0 to 1. Then if the lattice of set Q equals to 1, we suppose that the initial value of Q is 1 and Q bar is 0. For this, we suppose that the initial value is Q equals to 0, Q bar equals to 1. Q bar equals to 1 because with that. Then because R bar goes from 1 to 0, so the output will go from 1 to 0. Right? And Q bar from 0 to 1. Then the outputs make the transition when R bar goes low and remain in same state after R bar goes back high. From 0 to 1, the output will be 0 for Q. The output for Q bar will remain 1. Remains to 1. Because Q equals to 0. Q bar equals to 1. If R bar goes from 0 to 1, then the combination is 1, 1, 1, 1. Then 1, 1. We know that Q remains to Q. Q bar remains to Q bar. Right? And for this position, because the initial value is 0, the initial value is 1. Then if R bar goes from 1 to 0, then the output will be 0 because S bar equals to 1, R bar equals to 0. We know that S bar equals to 1, R bar equals to 0, then the output will be 0. Q bar will be 1. So the value will be remain to 0. Right? It remains to 0. Initial value is 0. And if R equals to 0, then the output Q will also be 0. Right? Right? That means S bar equals to 1, R bar equals to 1. We suppose that Q equals 0. Q bar equals 0. Because when S bar equals to 1, R bar equals to 1. This combination. Then Q equals to Q. Q bar equals to Q bar. We suppose that Q equals to 0. We initially reset. So when R bar goes from 1 to 0, then the output Q will also be 0. And the Q bar will also be 1. So there will be no change. And when R bar goes from 0 to 1, then Q equals to Q, Q bar equals to Q bar. So the output will always zero, always be zero for Q, and the output for Q bar will always be one. For this combination, S bar, R bar, S bar, R bar, there is no change condition. No change condition because Q equals to Q, Q bar equals to Q bar. Outputs do not change state. Latch remains set if previously set, and remains reset if previously set. And the last combination, invalid condition. This condition, right? S bar equals to 0, R bar equals to 0. If S bar goes from 1 to 0 and R bar goes from 1 to 0, the stimulus loads on both inputs. Then the output states are uncertain when input loads go back high. Note that. Take a note of that. Also, when S bar equals to R bar equals to 0, the output Q equals 1, Q bar equals 1. But when they go back from 0 to 1, S bar goes from 0 to 1 and R bar goes from 0 to 1, then the output will uncertain. We don't know if it is high or low.
Low, because Q equals Q, Q1 equals Q1.
Yes, because you know that, and when S bar equals 0, R bar equals to 0, then the output is 1. Q bar is also 1, right?
Yeah.
Then 1. But when S bar goes from 0 to 1, and R bar goes from 0 to 1, then 1 0. So 0 plus 0 equals to 0. 0 plus 0 equals to 0. 1 0. Then 0 plus 1 equals 1. 1 0 plus 0. The output is we know that when S bar equals R bar equals Q equals 1, Q bar equals 1. When S bar equals to 1, R bar equals to 1, right? S bar equals to 1, R bar equals to 1. Suppose that the output is 1, output is 1. And then S R equals to 1. S bar equals to 1. R bar equals to 1, right? Then 1. If we first suppose that the 1 of Q transmitted to this input first, then 1 0 1 0 0 plus 0 equals to 0, right? So Q bar will be changed from 1 to 0. 0 1. Then Q equals to 1. Then Q equals to 1 and Q bar equals to 0. This is the first condition. But if we suppose that Q bar value, the Q bar value 1, are first transmitted to this input, then because the input is 1 0 1 0, so the output Q will be goes from 1 to 0, right? Because 0 plus 0 equals to 0. So the output may be Q equals to 0 and Q bar equals to 1. Because Q equals to 0 0 1 1 0, so 1 plus 0 equals to 1. Q bar equals to 1. So there are two kinds of outputs. For S bar equals to 1, R bar equals to 1. This is not uncertain. Output states are uncertain. Maybe the value is 1, maybe the value is 0. So this condition is invalid condition. Invalid. So in most times we must not make S bar equals to 0 and R bar equals to 0. Gated SR latch. Gated latch is a variation on the basic latch. The gated latch has an additional input called enable. That must be high in order for the latch to respond to the S and R inputs. Okay, have a rest for 10 minutes. Enable. There are three inputs. One input are named enable input because it must be high. It must be high in order to make the latch work. This input must be high. Then the latch can work. Other, the latch will not work. D-latch. The D-latch is an variation of the SR latch, but combines the S and R inputs into a single D input as so. Like this. Because we know that S bar and R bar are not permitted to both one. So we can make s bar equals 1, r bar equals 0, or s bar equals 0, r bar equals 1. So we can use on inverter, and connect the two inputs to one input. So D equals to 0 or 1, but the value of these two inputs are outside, right? The value of the two inputs are outside. So we cannot find this combination or this combination in this diagram, right? Because S bar, it is S bar, R bar, right? S bar, R bar, and the input is S R S R S R. This bar D equals 0 or 1. The value of S and R, all the values of S bar and R bar are outside. They cannot be the same because there is only inverter. So if D equals to 1, then S equals to 1, R equals to 0. If D equals to 0, then S equals to 0, and R equals to 1. Right? Yes. So this the D latch is on variation of the SR latch, and the two combinations are not presented on this diagram. For simple rule for the D latch is Q follows D. That means Q equals to D. When enable is active, when En equals to 1. When En equals to 1. Others, Q will be Q. Q bar will be Q bar. Flip-flops, all flip-flops differ from a latch in the manner it changes state. A flip-flop is a clocked device in which only the clock age determines when a new bit is entered. The difference between flip-flops and latches is that the flip-flops is a clocked device in which only the clock age determines when a new bit is entered. The symbol. If the clock inputs are not presented on the diagram, then we call this symbol or latch. But if the input there is on clock input on the diagram on the symbol, then we call it a flip-flop. Because only the clock age determines
When a new bit entered, what?
the
This get a 5
output. When the clock edge comes, then Q equals to D. Other Q will remain to Q. Q bar will remain to Q bar. The active edge can be positive or negative. If we use this symbol, then the active edge is positive edge. If the input is like this, or small circle in the on the input, then it is a negative. The active edge is negative. So you must remember, positive edge, negative edge. And this is called D flip-flop. D flip-flop. And this is called JK flip-flop. JK flip-flop. The symbol is called dynamic input indicator. Dynamic input indicator. Edge trigger flip-flop. Edge trigger. And the output from on edge triggered flip-flop changes on the positive going or negative going edge of its clock signal. A bubble on the clock input indicates that it is a negative edge triggered flip-flop. This small circle is called a bubble. Big flop, for example, the dead bit and the D input is transferred to the component output on the edge of the clock signal. This means positive going, positive edge, active. The active edge is positive, so the order is on the positive edge, on the positive edge. So when the positive edge is come, then Q will equal to D. So before T0, Q equals to 0, and when the time is T0, then the output Q will equal to D, so the value will be 1. Positive clock edge. If already set means if already the output Q equals to 1, then it remains to 1. Q will remain to 1. If D equals to 0, then the initial value is 1. Then when the time is T0, the positive clock edge is come, and then the output Q will equal to D. So when the time is T0, then the value will be 0. If ready reset, it remains reset. If the initial value is 0, then the value will remain 0. we must understand the importance of the clock age. The clock age. Only when the clock age comes, the output will change or remain. Others, the output will remain. JK flip-flops, the values are the J and K inputs to a JK flip-flop determine its output state. The results of the four possible input combinations of JK are shown. For if J equals 1 and K equals to 0, then flip-flop starts on positive clock age. Q equals to 1, Q bar equals to 0. When J equals to 1, K equals to 0. And when J equals to 0, K equals to 1, then the output Q will be 0 and Q bar will be 1. So J is similar to a stack input. This is a set input, and this combination is a reset input. And then if there equals 0, K equals to 0, flip-flop does not change. Q will equal to Q0. If J equals to 1 and K equals to 1, flip-flop changes on each clock pulse. Total. It is different from SR latch. SR latch because the combination is active. The combination is permitted. J equals 1 and K equals to 1. The output will change to the offside value. If J equals 1, K equals to 1, Q will be 0 for the first clock and will be 1 for the second clock, and then will be 0 for the third clock, then will be 0 for the fourth clock. So the output will be like this. If the input clock is or log, positive age, then the output Q, in the first will from 0 to 1, and then from 1 to 0, and then from 0 to 1, and then from 1 to 0, and so on. In the first age, cultivate Q from 0 to 1, and in the second from 1 to 0. In the third, from 0 to 1. In the fourth, from 1 to 0. From 0. That is the function of the JK flip-flop. So we can get the expression of the Q bar. So what is the Q 加 Q bar plus K bar Q, right?
Oh, this is
Because J equals to 1, K equals to 1, then J equals to 1, K equals to 1, then Q equals to Q bar, right?
yes,
Right? 1, 0,
yes,
so,
0 plus.
and when J equals 1, K equals 0, then Q equals 1, right? Then J equals to 1, K equals to 0, right? Q equals to Q bar plus Q. For this combination, J equals to 1, K equals to 0, so K bar equals to 1. So the expression will be Q bar plus Q, right? Right? Q bar plus Q. Q bar plus Q will equal to 1, right? Right? Q bar plus Q equals to 1. So the output will be 1. Will be 1. For this combination, J equals to 0 and K equals to 1. J equals to 0 and K equals to 1. Then Q equals to 40. J equals to 0, so this term is 0. Please see the blackboard. J equals to 0, so this equals 0. And K equals 1. K equals 1, so K bar equals to 0.
0, this part is
So Q equals to 0. So Q equals to 0. And for the last combination,
1 of.
there J equals 0 and K equals to 0. Right? J equals to 0. J equals to 0. Then
Q.
this term is 0. And K equals 0.
Q equal to 1. Q
1.
equal to Q.
So Q equals to Q. So equals to Q. So the value will remain. The value will remain. Flip-flop or synchronous inputs. Synchronous inputs are transferred on the triggering edge of the clock. Triggering. Most flip-flops have other inputs that are asynchronous, meaning they operate independently of the clock. For this input, and this input. The two inputs are not controlled by the clock. Not controlled by the clock. Asynchronous flip-flop inputs are normally labeled press and clear. Preset means PRE, preset, and clear named CLR, clear. These inputs are usually active low active. All JNK flip-flop with active low, green stat and clear is shown like this. Note that the asynchronous inputs always override the synchronous inputs. Always override the synchronous inputs. And the flip-flop frequency division. Flip-flops can be used as frequency dividers, as shown below, like this, Q bar is connected to D. So the output will be Q equal to Q bar. So on each clock edge, the output will change from 0 to 1, from 1 to 0, from 0 to 1, from 1 to 0. So if the frequency of the clock is F, then the frequency of the output like this. The clock. If the frequency of the clock is F clock, the frequency of the output is FQ. Then what is the relationship between the two frequencies? What is the difference and what is the relationship?
What is the relationship?
Do you know the definition of frequency? Period and frequency. Do you know the definition?
1 over T, yes, T.
Definition. Yes, T is
1 over it.
is 1 by
The
F.
periodic time is equal to the 1 over frequency.
So F clock and FQ. What is the relationship between them? F clock equal to how many times?
1 over T is 1 over
Which time?
1 over TQ.
What?
F equal
F clock.
Q.
Yeah.
1 over TQ.
Yes. I want to.
What definitions I said?
I want to ask you. F block and FQ, they're different.
Yes.
They're different. So, what is the relationship?
Okay.
F block equals to which FQ? Wait. If F block is equal to 10, F block equal to what? Either period, right?
Yeah.
Either period. So,
This one.
so we know that.
5.
So we know. Oh, 5. Right. 5. So F block equal to 2 FQ,
Yeah.
right?
This is the technique.
Yeah. So complicated.
So,
So complicated.
2 clock is equal to 1 FQ.
Yeah, because TQ equal to T clock, right?
Yes, sir.
Right? If we suppose that the period of clock, the clock is T,
Sir, 1 clock is equal to 2 FQ or 2 clock is equal to 1 FQ.
yeah, yeah,
Which one?
1 clock is equal to 2 FQ.
yeah.
1 clock is equal to 2.
1, 2 clock. That is again that.
So if the period is T, then the period, the period of Q will be 2T.
1 by 2 FQ will be.
Will be 2T, right? Right. So it is can be used to reference division. Reference division because F clock divide FQ equals to 2.
For cycle they equals the frequency in the 4 cycle.
Periodic diagram. So for this diagram, there are 2 JK flip-flops. Then the first QA, the frequency of QA is half of the frequency clock. And QB, the frequency of QB is also the half of the frequency QA. Do you know? You know why? Do you know the reason?
This periodic time is not
Because QA is used as the clock input of the second flip-flop.
B.
So when the positive edge comes, on the positive edge, the value of the output will change. So on each positive edge, the value will from 0 to 1, 1 to 0, 0 to 1, 1 to 0, 0 to 1, 1 to 0. Right? So the period of clock, if the period of the clock is T, then the period of QA is 2T, and the period of QB is 4T, right? 4T because 2T plus 2T equals to 4T. So it can be used as reference devices. So FQA equal to half F clock, and FQB equal to half FQA equal to equal to 4 F clock over 4 clock by 4, right? This means this circuit is divided by 2 circuits. divided by 2 circuits. And the decade flip-flops on the right are cascaded to form or divided by 4 circuits. Divided by 4. Because the clock, the frequency of the clock and the frequency of the output is 4 times. And flip-flop counter. And flip-flops can be used to count the number of clock signals they receive. And so the receiver. So this diagram, we know that the frequency, the period of the output is 4 times of the clock period. And the output, we find that when the first clock, note that there are bubbles. So the active edge is negative edge. So negative edge. So on the negative edge, the value will change. For QA is this point. The first QA from 0 to 1, from 1 to 0, from 0 to 1, from 1 to 0, from 0 to 1, from 1 to 0, from 0 to 1, from 1 to 0. And QB, because the clock is QA. The clock is QA. So QA is used as a clock for the second flip-flop. So on the negative edge of QA, the value of QB will change. So the value will change from 0 to 1, and from 1 to 0, and from 0 to 1, and from 1 to 0. If we use the 2 bits if we see the 2 bits on decimal number, then we know that the combination is 0 0 0 1 1 0 1 1 0 0 0 1 1 0 1 1. The decimal number for the combination is 0. For the second combination, 0 1 is equal to 1, right? 1 0 is equal to 2. 1 1 equal to 3. And 0 0 equals 0. 1 1 is 1. 1 0 equals 2. 1 1 equals to 7.
1 0 equals to?
Yes. 1 0 equals to 2.
Oh, 1 this side. I count from this side.
Yes. High bit, MSB,
LSB. But I count from.
So we must remember that the last output is the MSB. The first output is the LSB.
Yes, sir.
MSB, LSB. So from this we can count the inputs. We can count the number of clock signals. Each clock input triggers the flip-flops, which are wired to toggle whenever triggered.
The QA and QB outputs indicate the number of clock inputs received.
Sir.
Flip-flop propagation delay. Propagation delay time is specified for the reading and falling outputs. It is measured between the 50% level of the clock to the 50 level of the output transition. Propagation delay. 50% of the triggering age, and the output cannot change the value cannot change as soon as possible. At the same time, it has a delay time. If the positive age present, then the output will change after TPLH times. This means TPLH delay. And if the output is changed from 1 to 0, then the delay time is called TPHL. P pause, L low, H high. So the delay time is from low to high. TPLH. And for this, because the output is from high to low, so the delay time is TPHL.
High to low.
Yes, high to low. Propagation delay is measured as shown in A, and the propagation delay TPHL is measured as shown in B. Okay, class is over.